My talk today has 5 parts. I'm going to very briefly talk about the differences and similarities between neural machine translation and large language models for translation. Then I'm going to very briefly talk about how the language industry has been transformed by automatic translation and more recently large language models in general. And then I'm going to address some legal and ethical issues with the use of AI in translation. And then hopefully the main part of my talk, if I time my talk well, will be about phenomena that I've observed in and outside the translator training classroom about translation with and without AI. So comparing human translation and automatic translation with different types of systems. Neural machine translation has been introduced to a larger public, I suppose, in 2016, 2017, via Google Translate and DeepL and other similar applications. And it's based on the idea that artificial neurons can evaluate and select a single output from multiple inputs. And once neural networks were used as part of machine translation, this improved the quality of automatic translation significantly. In translation, these neural networks are trained from parallel data for the different languages that are involved, and the building blocks are word, phrase, and sentence embeddings, which represent words as vectors of co-occurring words. This is a very, very simplified visualization of how this works. In the left-hand column, you've got different types of animals: dog, bird, fish, deer, and so on. And then you've got different categories that are either ascribed to them, in which case they're marked with a 1, or that are not ascribed to them, in which case there is a 0. So in reality, obviously, we have much more complex vectors. People sometimes speak of 1,000-dimensional vectors. So similar concepts will end up having or similar vectors as well. I have to also say that I'm talking about this as somebody who's purely read about this and not programmed anything. Neural machine translation systems divide segments, which are usually sentences, from training data into tokens, which are normally words, and encode them as numbers. And at first, the weights between these neuron connections are random, but by repeatedly making new connections based on new training data, NMT systems are trained to produce more and more appropriate output. And the best possible predicted translation of a new input segment is produced based on the typical proximity of words in the source language compared to the typical proximity of words in the target language. So far, so good. Now, the transformer model is the most popular architecture in neural machine translation, and it consists of an encoder and a decoder. And it was introduced in 2017 by a group of Google employees. And unlike previous encoder-decoder architectures, it processes text not serially or word for word, but it learns to first process what is most important. And for this purpose, it uses multi-head attention. So there is an attention mechanism in the encoder, and 2 are in the decoder. And this enables parallel data processing and also the processing of larger context windows. Before this type of architecture was used, it was difficult for machine translation to handle longer sentences. And the output quality has improved significantly with this approach. Translation with large language models is a fairly new thing, obviously, but for now I'm just going to say that large language models were not made for translation, but are surprisingly good at it. This paper from 2023 compares NMT systems and large language models on general terms, and they're both using a transformer architecture, but whereas NMT systems have an encoder and a decoder, large language models have a decoder-only structure. And NMT systems are trained on large amounts of parallel data, whereas large language models are, of course, trained in different languages, but they're basically trained on monolingual data. So there should be a stronger bias towards English. For NMT systems, even though they require a huge amount of training material to achieve strong multilingual in-context capabilities, comparatively speaking, less training material is required. This is a talk by Arl Lommel from the AI in Translation Summit in November 2023, and he compared Google Translate and GPT-4 for translation based on different criteria, comparing the performance. As far as context is concerned, large language models have a better grip on context, which in practical terms means that if you've got a longer text, say about a Lehrerin, and translate that into English, the pronouns are expected to be more aligned if you work with a large language model. NMT systems are faster, quite significantly faster to date at translating. On the other hand, large language models are better at adjusting translations different audiences. This is something you can't do with an NMT system quite yet. NMT systems are comparatively less bad at dealing with under-resourced languages, even though both types of systems have serious problems with smaller languages. But the process for improving NMT systems is also clearer. NMT systems are easier to retrain and also integrate with other translation tools, such as CAT tools that we use. They're comparatively less expensive, and they're also more advanced when it comes to data security. So in conclusion, Lommel suggests that large language models are unlikely to replace neural machine translation systems, but are driving them to get better. So how does automatic translation perform, and how is it assessed? I mean, generally speaking, we can say that it performs well, otherwise we wouldn't be talking about this. But there are still mistranslations, which neural machine translation fluency, especially for high resource languages, such as English, can make difficult to spot. Inconsistent terminology may be used as word embeddings permit variability. So the word verkehr, for instance, might be translated first as traffic and then as intercourse in the next sentence and then maybe as something else. But term accuracy can be improved when the source terms are annotated with their target translation. So for this purpose, DeepL has a glossary function now for some languages, not for all languages. There are still problems with register or levels of finality. NMT output is less lexically diverse than the underlying training data, as the most frequently words tend to be chosen. And it also reflects and exacerbates human bias. I suppose we can't really accuse these systems of being biased, but the training data show or mirror bias, and that's what comes out. They may use incorrect or varying grammatical gender output, and there are still some hallucinations where the output may have no relation to the source segment or to other target tokens. And when this happens, it is usually due to data sparsity. How is NMT quality assessed? Mainly, it is human evaluation using judgment metrics, error annotation, or task-based evaluation. But there is also automatic evaluation, and for this, Bleu is currently the most popular framework, but there are others, and it's mainly used at this stage to measure whether quality improves or converges in NMT training. Neural evaluation is the most recent thing, and it has reached a stage where it is used in the industry. Normally, after machine translation, there is some degree of post-editing, and I want to mention some phenomena that occur in post-editing. One of them is priming, which means that once translators see a machine translation proposal, it can be difficult to think of alternative ways to phrase a given passage. But there is also the opposite phenomenon. Some people who use machine translation want to change everything because they have often this is directly linked in research on this to negative attitudes, and these negative attitudes are often also linked to a lack of familiarity with this technology. So this, I think, shows one of the paths into the future for language mediators in training. Sometimes the result of post-edited machine translation is also called post-editees. This is not an uncontroversial term, but anyway, there are some researchers who find that the translations that are post-edited tend to be simpler and show more interference from the source language than human translations. Large language models have also been used for translation, and there have already been some reviews of how they perform. And the three researchers that are represented in this slide come to slightly different conclusions. Gao et al. Say that large language models usually show weaker performance than NMT systems, but you can enhance their performance with good prompts, which should contain concrete information about the translation task, as well as the context domain telling the system whether it's a piece of news or a literary text, and also part of speech or grammatical tags are supposed to be helpful. Jiao et al. Say that ChatGPT performs significantly better with GPT-4 as engine, and it also seems to produce better translations when the translated texts echo the spoken language. And Li Tongqing is the only researcher I've consulted that says that ChatGPT already matches or surpasses the most common NMT systems in translation. And he particularly highlights the fact that you can adjust the output bias depending on your prompt. Under-resourced languages, as we've said, are a problem for both types of systems. And I mean, I just looked at the Common Crawl archive. This is representation in the pie chart from October 2023. So you can see that English makes up almost half the overall language output on the internet, and the top 10 languages make up 83.19%, which leaves very little space for all the other languages. So how has automatic translation transformed the language industry? This section is short, but I consulted the European Language Industry Survey report from 2023. And according to the international language service companies, the freelancers and the academic respondents involved, machine translation continues to be the dominant trend and also the dominant area of investment. And it is estimated, according to this report, to be used in more than 30% of translation business, which strikes me as very little. But it is said elsewhere in the report that machine translation is used less in the industry than we might expect. I just want to read out 3 quotations from the report. Machine translation dominates the trend list, both on the positive and the negative side, closely followed by and often in direct correlation with price pressure. So in other words, machine translation is perceived as enhancing productivity, but it's also perceived as something that makes it difficult for language service providers to charge fair rates for their work. AI, I suppose meaning large language models, is considered exclusively as a threat in 2023. And a majority of academic respondents estimate that by 2030, at the latest, machine translation will be used in most professional translation work. But there are also 17% who think that this will never happen. Okay, there are definitely some ethical and legal issues with the use of AI in translation, which are important to address, I think. I'm going to start with the use of MT technology in high-risk situations, and this is an example that a colleague from Leeds, Binur Wang, has drawn my attention to. Within the NHS, the use of automatic translation without human supervision has been linked to patients experiencing adverse health effects. This is a BBC News report from November 2023. It is said in this report that there are often no interpreters these days, or after the COVID pandemic, there has been a habit of only using a telephone service, and this has also been linked to communication difficulties. So apparently a recent investigation prompted by a Sudanese mother's death in childbirth found that of the total 2,607 reviewed cases, 80 included references to interpretation and communication problems due to language difficulties, which it therefore considered to be a contributing factor to death or brain injury. Now, I'm moving right on to literary translation, where, of course, the effects of a poor translation are far less immediate, but I still want to talk about this. This is an example that a colleague from Vienna, Waltraud Kolb, has drawn my attention to. Some publishers offer automatic translations of literary texts already for sale, cheaply, with limited post-editing. Okay, and one of the publishers that has been mentioned by literary translators is Rosson Press. And on their website, they present their approach to literary translation as follows. Using a system of AI-assisted team translation, our skilled editors are able to create high-quality literary translations with a fraction of the resources which traditional methods require. This novel translation method means that we can bring readers more titles than conventional publishers of translated fiction, while taking a much smaller slice of the pie away from authors. While I'm not, I don't object to the use of automatic translation in a context of literary translation, but I do think that high quality literary translation has to pay close attention to so many things, including content, form, an author's literary voice, but also the receiving situation, the cultural situation in which a translation will be received. And I think that these things are difficult to reconcile with both AI tools and team translation, let alone a combination of the two. And I also want to point out the incrimination of translators for impoverishing authors, which in my opinion shows that the art of translation is acutely undervalued in this statement. According to Taivalkoski-Shilov, low-quality literary translation can harm original authors' reputation and the status of their work, and it can also harm readers who are entitled to the same literary quality across languages. And there is a potential solution to this problem, maybe, which is offering high-quality literary translation that is affordable due to effective workflows, which may combine automatic translation, a bilingual post-editing process, and a final, predominantly monolingual revision process. There has been a conference paper by colleagues from the University of Ghent, and they have collaborated with a publisher called Nuance, which is using this approach. And in the limited corpus that they've studied to date, they have found that after the final revision process, there is little perceived difference between a human translation and a post-edited machine translation. There are some very fervent advocates of human language in our day and age, and due to time constraints, I don't want to comment on them for now, but I want to give them space in my presentation. This is from an open letter from professional associations of translators from Austria, Germany, and Switzerland. And this open letter was published a few weeks or months ago. It was in 2024. And it concludes with a manifesto for human language. And I'm just going to quote parts of items 5 and 6. Maschinensprache täuscht die Leserinnenschaft über Autorschaft und Wahrheitsanspruch. Die Bezeichnung Übersetzung wird im Kontext von KI-Systemen für eine Maschinensprache verwendet, hinter der keine Person steht und die nichts mit der genauen, reflektierten und verantwortungsvollen Arbeit einer menschengemachten Literaturübersetzung gemein hat. Another quote, damit wird unter anderem das Ökosystem des Literaturbetriebs geschädigt, in und von dem sprachschöpfende Leben, Ausbildung und Austausch organisieren und das Wissen und die Wissenschaft vom Übersetzen entwickeln. This is another quote from a self-published book by the Swiss translator Ettore Mjörsnes, and his book is called Der stumme Text, eine Kritik der maschinellen Übersetzung. So he argues that machine translation output is silent because it only creates a textual surface without any anchoring in the hinterland of lived experience or knowledge, we might add. Die maschinelle Übersetzung hebt die Dialektik des Übersetzens auf und ersetzt sie durch eine rein mathematisch begründete lineare Zuweisung von Graphemen, deren außer mathematischer, menschlich bedeutungsvoller Sinn, wenn überhaupt, erst durch einen zweiten, der mechanischen Umwandlung nachfolgenden Schritt zustande kommen kann. Deswegen ist die maschinelle Übersetzung letzten Endes stumm, egal wie eloquent ihr Wortgeräusch daherkommt. Okay, I'm going to move on. Now we're talking about legal and ethical issues. I'm briefly going to touch on translation copyright, which was already complex before the use of AI came into the picture, because the relationship between originals and translations is really very complex. And I can't go into this complexity, but I just want to mention two diametrically opposed positions. The oversimplified assumption that is sometimes made that a translation and an original text can be identical. This, historically, has often resulted in translators of big literary texts not even being mentioned on the book covers of the books that they have translated. There is, on the other end of the spectrum, an academically informed position, mostly, but not exclusively promoted by Lawrence Venuti, that translation is so radically decontextualizing that it changes everything about an original text, because an original text has no invariant core, and everything is, up for interpretation. This arguably applies to some texts more than others, and I suppose it's informed by deconstructivism in the context of literary translation, or just translation generally, not just literary translation. But I just want to show these positions to show that translation copyright is complex. The identity of a translation is something somewhat precarious. So translation studies has a history as a kind of marginalized discipline with a precarious identity. And there are some people who think that this is now an advantage over other fields of work that see their identity questioned, if not threatened, by artificial intelligence. Translation copyright was first defined by the 1886 Berne Convention for the Protection of Literary and Artistic Works. And it was established that original authors own their own texts as well as translations of these texts. But on the other hand, translators also own their translations. And with some amendments, the original Berne Convention is still in place. And by November 2022, it had been ratified by 181 out of 195 countries. Essentially, translators only can use their translations if the authors of original works have given their consent, but of course, eventually copyright expires. To date, a translation produced by a machine is not capable of copyright protection, but of course the code of a translation program can be protected. And if an author uses machine translation as a supporting tool, but the translation is the result of their own intellectual act of creation, copyright still applies. In their terms and conditions, DeepL renounces the copyright for translations made by using their translation service, both for the free and the paid version. With the free version, they're explicitly stating that you are not allowed to forward their online service to third parties for money, I suppose, without making any changes. If copyrighted texts are translated with DeepL, they can, of course, be used as training data with the free, but not the pro version. So it's definitely legally problematic to enter personal data in the free version, and it's potentially legally problematic to enter copyrighted text in the free version as well. Large language models are making the issue of copyright more complicated again, because automated web crawlers regularly troll the internet for new contents, and we don't know what this is going to look like yet, but the AI Act envisages a machine-readable digital watermark that tells AI models that something is copyrighted and not to be used. So the current EU regulation on text and data mining only protects copyright owners that explicitly opt out of allowing the use of their data. Okay, I'm moving on to phenomena now, and I've got a number of different examples of things that I tried out. I want to start with the first general term, the GIGO principle, garbage in, garbage out. And while it's not fair to say that the information on this website about the use of artificial intelligence in a care situation is exactly garbage, it's not the most well-written text. And if you look at the DeepL and ChatGPT translations, I suppose, if anything, if you put in a poorly written text, what is going to come out is definitely not going to be any better, which in terms of, as was framing this in terms of sustainability, is significant. I just want to show one example or read one sentence as an example. Sobald beispielsweise Roboter in der Altenpflege eingesetzt werden sollen, müssen die Maschinen auf kleinste Gesten reagieren und Druck regulieren können. We don't know, looking at this, whether this is about blood pressure or the pressure in the heating system or friction between humans. And obviously the machine translation is only going to be as good as the original text, if not worse, right? I want to show some phenomena based on a very short piece of literary prose by Virginia Woolf. We're only going to look at the section called Blue from this literary diptych called Blue and Green, which is a bit more than 100 years old and which was first published in a short story collection called Monday and Tuesday. And the story or the sketch is based on an attempt to combine literature and other art forms. In this case, it's very much about visual art. And to kind of say at a very simple level what the plot of the text is, it's about a fish being caught. Okay, and I'm just going to read out the English original version, and you may read along or maybe just look at the highlighted passages in the human translation from 2021, a retranslation, and the DeepL and the ChatGPT version. The snub-nosed monster rises to the surface and spouts through his blunt nostrils 2 columns of water, which, fiery white in the center, spray off into a fringe of blue beads. Strokes of blue line the black tarpaulin of his hide. Slushing the water through mouth and nostrils, he sings, heavy with water, and the blue closes over him, dousing the polished pebbles of his eyes. Thrown upon the beach he lies, blunt, obtuse, shedding dry blue scales. Their metallic blue stains the rusty iron on the beach. Blue are the ribs of the wrecked rowing boat. A wave rolls beneath the blue bells. But the cathedral's different, cold, incense-laden, faint blue with the veils of Madonnas. So comparing the human translation and the DeepL and the ChatGPT versions, it is obvious that the human translation is significantly shorter. Now, this is not necessarily characteristic of translation processes. The human translator also more often abandons the original wording, whereas the DeepL and the ChatGPT versions are much closer to the original wording. DeepL and ChatGPT, unsurprisingly, produce some errors and some stylistic weaknesses. I just want to point out one. Blunt and obtuse are used alongside each other in the original text as 2 similar adjectives, but that are combined for emphatic reasons. And in the DeepL version, you just get stumpf, which is not much of a literary effect. And in the ChatGPT version, what you get is not much better, stumpf, abgestumpft. Okay, there are examples in the automated translations of what some people call translationese. An example, faint blue with the veils of Madonnas, is translated as blassblau or schwachblau mit den Schleiern der Madonnen. That wouldn't be a likely preposition for someone to use in German. And the human translator makes occasional interventions. I mean, we have to also remember that the text is more than 100 years old, so I suppose printing was a different story then. And she thinks that the author probably wanted to say singt rather than sings about what the monster is doing. And the bluebells are very probably Glockenblumen, in which case they would have to be written as one word. And so these are, of course, interventions that machine translation doesn't make. I also prompted ChatGPT to translate and simplify the text for a target audience of children aged 6 to 8 years. And we're not going to read the result, but I want to say that it does largely reproduce the key images from Wolf's text with simplified expression and syntax. So quite impressive, I thought. But there are also changes and additions to the original text, which I think we'd have to be careful about. An example, the snub-nosed monster rises to the surface, becomes das kleine, dicke Monster. Okay, the adjective isn't anywhere in the source text. I suppose it's in integrity with the overall description of the monster. There are also bubbles then in the image about the 2 columns of water. The blue closes over him, which kind of describes the monster being submerged in the water, becomes a very abstract, das Blau umgibt es. And I think this is the most interesting one here. Faint blue with the veils of Madonnas. The religious symbol is dropped in the translation simplification. And what we've got is, I suppose, a very biased description of this symbol. I'm going to very briefly talk about translation of slang based on a novel by the Irish author Kevin Barry from 2019, Night Boat to Tangier. And it's a novel about 2 Irish drug smugglers in their 50s who wait for someone in the harbor of Algeciras in Spain. And the interesting thing is that the novel is largely told via the direct speech of these 2 main characters who use an Irish-English slang from the Cork region, so something very specific. So it's about a young girl we're looking for, Maurice says. That man's daughter we're looking for. The man hasn't seen his daughter in 3 years. Photo's a bit old now, but she'd still have the same kind of gouge to her, I'd say. Maurice, they're not going to know gouge from their fucking elbows. What you can see, the human translator here, I suppose, used something also completely different, used a term that Duden labels as bildungssprachlich to, I suppose, introduce the foreign. And it's no surprise that neither DeepL nor Google nor ChatGPT, produce something that is even remotely useful. I suppose Blick would be an example of hallucination. And what often happens when there is unfamiliarity is that the source term is just retained. Okay, 2 more examples to go. This is from a children's book, Spuds and the Spider by Seamus O'Connell from 2018. And it is a book about a leprechaun called Spuds Pots of Gold and his wife called Rose Goody Two Shoes. And we're just going to look at the names of these 2 characters because they are what we call in German sprechende Namen, or character names. They are names that tell us something about these characters. Spuds Pots of Gold is called what he's called because spud is a colloquial term for potato, and potatoes have a big significance in Irish history, but also looking at his nose maybe looks a bit like a spud. And he's called Pots of Gold because leprechauns, which are creatures from Irish folklore, they hide a treasure often at the end of the rainbow. So this tells us the story. And I used this text in a literary translation class and then also later in a creative writing class. And I translated the same passages with DeepL and ChatGPT 3.5 and 4. And I highlighted Topf voll Gold and Töpfe voll Gold because the translation that ChatGPT produced is very similar to what years earlier a human produced. And what this shows me is that for this type of text or wordplay, ChatGPT could be potentially useful as a source of inspiration. And with the next name, Rose Goody Two Shoes, I highlighted a human translation and the ChatGPT version, and these versions are obviously very different. We've got Tugendfee and Bravschuh. And I want to say that ultimately the best possible translation would combine these 2 notions, because Rose Goody Two Shoes is called Goody Two Shoes because she's a Goody Two Shoes, which means that she's a person who's extremely virtuous and always wants to do the right thing to please people in authority. But leprechauns, of course, also mend shoes. And this is something which I suppose in a child that is reading the story would immediately ring a bell. right? And so you could possibly, so I think that these AI tools are good at reminding us of the significance of the textual surface level. And I suppose in the next step, you could also try to prompt ChatGPT to come up with potential combinations of these two concepts into an original name. I found ChatGPT useful in coming up with, you know, playful titles, so why not try this, right? I haven't done it yet, but it's something that you could do. This is a rhyme from the same text. He means no harm, let him go, just be kind, you never know. This is what Rose Goody Two Shoes says to her husband. And obviously, or not obviously, I mean, the literary translators that I asked to translate this passage all came up with rhymed translations into German. DeepL, in my, or from my experience, cannot recognize literary form in a source text, and it can't produce it in a target text. ChatGPT, when I asked ChatGPT to rhyme the same passages in the source text, wasn't able to do this. So it seems to me that it can't recognize literary form in the source text, but in a next step, I suppose you can prompt it to use rhymes in the target language. And I suppose if you wanted the same passages to be rhymed, then you would have to probably tell ChatGPT where exactly you want those rhymes to be, and that might work. Okay, I'm not going to go into how useful these exact rhymes are, but I suppose they're somewhere to start. And this is my last point, and then I'm at the end of my presentation. And I mean, I'm only beginning to think about this, languages other than English. And I'm working with my 3 working languages. And then, I mean, I haven't even been working much with Spanish in the last 10 years or more. But I suppose, according to the latest Common Crawl archive of the language use of the internet, English is still obviously in first position. And then, you know, for a long time, nothing else comes. Then I think it's Russian. German is in 3rd position with roughly 5%, and Spanish is in 5th position with 4.6% of the overall language output. It would be much more interesting, I suppose, still to add Romanian, but I don't know Romanian, and I also don't have a Romanian translation of this book because Romanian, say, makes up, you know, only 0.5% of the overall language output on the internet. So it's a low resource language. So I'm working on the assumption that automatic translation between English and German should be stronger than between Spanish and German. And I have experienced this when translating emails that I was going to write and editing them. But I suppose I've only looked at a very kind of limited corpus for now. So what I did was I looked at Yoko Tawada's exophonic writing. So Yoko Tawada is an author who writes both in Japanese and in German and publishes very successfully in both languages. And there's a book that she had written originally in Japanese and that she wrote again, slightly differently, in German, called Etüden im Schnee. And I happen to have the English and the Spanish translations of this book at home. So what I did was I put down the original German passage and then the human translation into English by Susan Banowski, and then the human translation into Spanish by Belén Santana, and I back translated these translations into German. I suppose the human translations are, of course, you know, in no way identical, but I wanted to see whether what I got would be better for English German. And I mean, this might be a coincidence, but in this translation from the Spanish, I've got errors, you know, quite obvious ones, based, I suppose, mostly on the fact that the verb, the Spanish verb encogerse, can mean a whole lot of different things. It can mean shrink as well as shrug. So we've got a very heterogeneous set of translations. We've got schrumpfte, zog mich zusammen, zuckte zusammen, you know. So there obviously, you know, in this short segment, more problems, but, you know, it's way too early to make any conclusions. And I suppose it could be based on this verb, but then on the other hand, you could also say that, you know, Spanish has this feature that verbs can have very many different meanings depending on the context, as anyone who's ever tried to study perifrasis verbales in Spanish would know. Okay. I'm concluding. So DeepL and ChatGPT show a similar performance for the translation of the examined texts with German and English, and also German and Spanish as language pairs. There seem to be more problems when English is not involved. ChatGPT tends to produce better results than DeepL, but according to the latest research and also the Ellis report, large language models are still unlikely to replace NMT systems. Both NMT systems and large language models can increase productivity and creativity in human translators. There is, of course, also the risk of priming by the machine translation output that we've already talked about. I do think that sustaining a healthy linguistic environment requires an effective combination of human and artificial intelligence in most areas, if not all areas of translation and interpreting. And for this reason, future translators need to develop a solid amount of AI and MT literacy. There have already been publications on that. And I don't want to end this talk without once more saying that there are definitely legal and ethical questions that must be addressed. Thank you very much.